Object-oriented design using the UML. So in this section, we are going to discuss about system context and interactions. System context models and interaction models present complementary views of the relationships between a system and its environment. Now this figure shows you the system context of weather station system. That is, it shows the environment of the weather station. It is having four classes and association between those classes is shown in the figure. The four classes are control system, weather information system, satellite class, and weather station class. And you can observe the associations between these classes. Next, they have taken two classes, that is the weather station information class and control system class. Weather station information system class and the control system class have been taken, and they're showing the roles by using the use case diagrams. You can observe in this figure weather information system and control system. They have taken these two classes and they're representing them in the use case diagrams. So weather information system can report the weather and it can report the status. And next, control system, it can restart the system and it can shut down the system, or it can reconfigure the system, or it can go to the power save mode, and it can go to the remote control state. So these are all the use case. This is the use case diagram of the weather information system and the control system. Next, we shall move to the architectural design. So once the interactions between software system and systems environment have been defined, we can use this information for designing the system architecture, so that we can identify the major components of the system and we can organize those components using an architectural pattern such as a layered or a client server model. So this figure shows the layered or client server architectural model. It consists of many subsystems in it, such as fault manager, configuration manager, power manager, communications, data collection, instrument, subsystem. So these are all the subsystems attached or connected to the communication link. So they have taken data collection subsystem and have designed an architecture for that. They have taken data collection subsystem and they have designed an architecture for that system. So it consists of transmitter, receiver, and weather data class in it. Next, we shall move on to the object class identification. By this stage in the design process, we should have some ideas about the essential objects in the system that we are designing. As we have taken weather station system as an example, the figure shows what are all the objects a weather station system consists of. So it consists of 5 object class, that is a weather station object class, weather data object class, ground thermometer and anemometer and barometer object class. So this weather station object class, it provides the basic interface of the weather station with its environment. So then what do weather data object class will do? This is responsible for weather data object class is responsible for processing the report weather command and collecting the data, and it sends the summarized data from the weather station instruments to the weather information system. So you can observe the operations here: collect and summarize. That it collects the data and sends the summarized data from the weather station instruments to the weather information system. Next, this ground thermometer, anemometer, and barometer object class. So these three classes are directly related to the instruments in the system. They reflect the hardware entities. So these are all the 5 object classes you can see in the weather station objects. So far, we have discussed what is object-oriented design using the UML. For that, we have taken system context of the weather station, and we came to know what are the classes that are involved in the weather station system, in the system context of the weather station. So then they have taken two systems, that is weather information system and control system, and they have represented them in the use case diagram. Next, we came to know that weather information system can report weather and it can report the status. Then control system can restart the system, or it can shut down the system, or it can reconfigure the system, or it can take the system to the power save mode, or it can remote control the system. Next, architectural design. We have seen that many subsystems are connected to a single communication link, and it is a layered or a client server model system. Next, in this subsystem, they have taken a data collection system, and they have shown an architecture, that is, they have designed an architecture for that weather data collection system. For it involves transmitter, receiver, and the weather data class. Next, in the object class identification topic, we came to know the weather station objects. So there are 5 weather station objects: weather station object class, weather data object class, ground thermometer, anemometer, and barometer object class. Then they also explained that weather station object class, it provides the basic interface of the weather station with its environment, whereas weather data, it is responsible for collecting and processing the report weather and sends the summarized data from the weather station instruments to the weather information system, whereas the ground thermometer, anemometer, and barometer classes directly related to the instruments in the system. They reflect the hardware entities. In next session, we shall discuss the design model. Thank you.